Alright, next mechanism is the secondary migration, which it takes place from the carrier beds to the trap and leading to the accumulations in the reservoir rock. Okay, so for the migrations, secondary migration to occur, we need three forces, right? So there are three forces involved, okay, which capillary pressure, buoyancy forces, and also additional forces of hydrodynamic flow fluids and isolated abnormal pressure. Okay, so for the secondary migration to occur, okay, there should be a work that is required to increase the surface area of the oil-water interface to force the oil phase through the smaller pore throats of a confining bed. So meaning here, we need a sufficient pressure to force the hydrocarbon into the connected pore throats of a rock. Okay, so the first force that we need is the capillary pressure. Okay, it means that this pressure is actually required for the oil or gas to displace the water that exists in the rock that it is trying to penetrate. So this capillary pressure is actually served as the resisting force at the rock water system. We need this capillary pressure as minimum as can, so that the hydrocarbon can easily penetrate the pore in the rocks. But this capillary pressure at the oil-water interface must exceed the displacement pressure in the displacement area. Okay, so for any specific combinations of oil, water, and pore, the displacement pressure is a constant value. Okay, on the other hand, the capillary pressure is actually depend on the buoyancy, pressure gradients, and the length of the oil phase. So if the forces are sufficient to cause the capillary pressure to exceed the displacement pressure, right, the oil will enter and pass through the pores. So there are three controlling factors, okay, that control the capillary pressure. So we have the interfacial tensions, we have the wettability, and we have the radius of the pore throat. For the interfacial tension, okay, at the standard temperature and pressure, normally oil will migrate more easily than gas through water wet rock, because the oil water system usually has lower interfacial tensions that will later result in the lower capillary pressure. Okay, and then wettability is actually expressed as the contact angle between the rock and hydrocarbon. So if the angle, right, is equal to 1, it is for wet water rock, and also represent a rock that have as much as 25% of oil wet surface, right? Next, the third factor is the radius or the diameter of the pore throats, right? If the buoyancy of the oil or gas columns does not exceed the capillary pressure, a trap will have changes in terms of their permeability. So majority of the rock in the subsurface are actually water wet, okay, in which this water can pass uninhibited from the source, from the sandstone to shale, but the oil that is trapped by the capillary barrier of the fine and water wet pore openings, because the pressure that developed by the capillary barrier are enormous or big. So a globule of oil, okay, or globule of oil that attempt to enter the shale from a sandstone would be rejected from the shale by a pressure developed by the capillary barrier, and plus any change from the coarse to fine particle size will be resulting in some accumulations of oil. Okay. Next, the second force that we need is that is a main driving force that proceed this secondary migration is the buoyancy. So the buoyancy of the hydrocarbon. So buoyant forces here refers to the difference in density between the hydrocarbon phase and the water phase. The greater the difference is, the greater the buoyant force will be for a given hydrocarbon column. Okay. So if we compare the hydrocarbon column, buoyancy, pressure, and seal efficiency, right? A gas column will has more than 3 times of the buoyant pressure than an oil column in the same length of column, because gas forces its way into the smallest into this shallowest part of a trap above the oil and water due to its small molecule. That's why methane is observed and found as a dominant in oil and gas process. Plus, under average surface condition, gas has about twice than migration potential of oil, because its buoyancy more than overcomes the higher interfacial tension and gas water system that relative similar to oil water system. Alright. So the buoyancy and the hydrodynamic flow fluids actually trap the hydrocarbon in 2 ways. First way is when the hydrocarbon entrained in following water reach an anticlinal area, their buoyancy causes them to resist further movement. Okay. For the second way, you can see here the oil and gas migrate up deep by the buoyancy until buoyancy or capillary pressure has no longer exceed the displacement pressure. Okay, you can see here if the strata is down deep, okay, the water will flow in down deep directions, right? So the oil globules, meanwhile for the oil globules that are less density than water, will moving to the upwards directions, which against the water directions, and therefore it will cause the oil globules to be rejected from entering the displacement compartment. Okay. On the other hand, if the strata is up deep, right, the oil globule can enter the displacement area or displacement compartment easily by the help of buoyant force and hydrodynamic fluid flow forces, although the pressure exists in the displacement area is higher. So that's why we need the both buoyant force and hydrodynamic flow fluid force to overcome and lead and let the oil globules to enter the new pores to the permeability pathway. Okay. Alright. Next, after the secondary migration, right, we need also the migration pathway as one of the elements in the petroleum system. Okay, so we divided into the vertical pathway and the lateral pathway. Okay, for the vertical pathway, it's more efficient, but less petroleum is collected, because although it's offer a short distance of migrations for petroleum from the traps to from the carrier beds to the traps, right? But basically it has less petroleum that will be preserved in the reservoir rock, because the individual structure drains only has the relatively small areas directly below them. Okay, for instance, delta, which has only 5% of produced oil in the basin. Okay, so for the vertical pathway, normally the migration path that will take place or that will help in the migrating of the petroleums through secondary migration, it's a joints, faults, and ligaments. Okay, so joints here is the most ambiguous structure, in which it is the tension fractures with no visible offset. So normally it formed by the internal fluid pressure that has slightly excess of the least comprehensive stress in a sedimentary rock. Okay, fault is the faults. For reverse faults, it have lower permeability than do the normal faults. Okay, and fluid will travel more readily along the active moving faults, and if the faults stop moving, it will become sealed and later will prevent further migrations. Right, for lineaments, it represents as the higher permeability pathway to the surface because there will be increasing of fracture density or spacing when approaching the lineaments. Okay, next we have the lateral pathway, right, as the one of the type of migration pathway. So normally unconformities, sheet and channel sandstone, right, will act as the migration pathway unilaterally. So it's less efficient, but more petroleum is collected because it can form a large or a huge drainage area of petroleum reserve, and thus the compartment can drain more petroleum from a larger volume of source rock. Okay, for instance, for land basin and footbeds. Okay, so unconformities here uh, is actually as a condensive of harboring traps, which represents more permeable migration pathway, particularly when they are overlain by a massive sheet sandstone. And many oil fields are related to unconformities, and many seeps occur at the outcrop of an unconformity if the unconformity uh, acting as the controlling factor of oil migration.